You have probably heard it before, that quick, uneven popping sound from a microwave bag, a hot pan, or a machine at the movie theater. Heat the kernels, wait a little, and a handful of hard seeds become something white, light, and crunchy. But here is the strange part. Take sweet corn from the market, canned corn from your kitchen, or dried kernels from an ordinary cob, and the same trick will not really happen. They may burn, crack, or dry out, but they will not become the fluffy popcorn we know. So why does popcorn burst open while most other corn simply sits there in the heat? The answer is not hidden in the pan or the microwave. It is built into the kernel itself. Let's get into it right here on Secrets of Simple Things. Popcorn came long before movie theaters. To understand why a corn kernel can burst open like that, we first need to clear up one thing. Popcorn is not a modern snack invented for cinemas. People knew about it thousands of years before microwave ovens, paper buckets, or butter-flavored toppings. Archaeologists have found ancient popcorn kernels in caves in present-day New Mexico, some dating back more than 5,000 years. Long before Europeans arrived in the Americas, Native American communities were already eating popcorn, trading it, and even using it for decoration. Much later, in the late 1800s, steam-powered popcorn machines helped turn it into a popular street food. During the Great Depression, popcorn gave people a small treat at a low price. Then movie theaters made it famous in a new way. But that long history still leaves the real question untouched. Why can popcorn do this when most other corn cannot? Corn is not just corn. It is easy to look at corn and think it is all basically the same plant. But around the world, corn comes in many varieties, and they have been bred for very different jobs. Sweet corn is the kind most people eat on the cob. It is harvested while still young, when the kernels are soft, juicy, and high in sugar. Dent corn, sometimes called field corn, is grown on a much larger scale and used for animal feed, corn syrup, ethanol, processed foods, and many industrial products. Then there is flint corn, which has a harder outer layer. You may see it used for decoration, especially in colorful ears of corn, or ground into cornmeal. Popcorn is a special type of flint corn, but it is not just flint corn with a better name. Its kernel is built for one unusual job, bursting open in the right way. So the difference is not just cultural, it is physical. And if you could cut open a popcorn kernel, the secret would not be its size. It would be 3 tiny parts arranged almost perfectly. What is inside a popcorn kernel? A popcorn kernel may look dry and quiet, but it is more like a natural pressure vessel than a simple seed. On the outside is a tough layer called the pericarp. This is the hard skin of the kernel. In popcorn, it is unusually strong and tight, so moisture does not escape easily. Inside that shell is the endosperm, the starchy part of the kernel. This is the material that will eventually become the white, airy part of popcorn. Before it pops, it is packed tightly inside, waiting for heat to change its texture. Hidden in that starchy center is a small amount of water, not a puddle. Usually, popcorn kernels contain about 13 to 15% moisture. That number matters more than it seems. If the kernel is too dry, there is not enough water to create the pressure needed for popping. If it has too much moisture, the kernel may heat unevenly or fail to expand properly. Popcorn works best in a narrow middle zone. At this stage, the pericarp holds everything together long enough for something dramatic to happen. When a popcorn kernel is cold, all of this seems still and harmless. But once heat enters, that tiny sealed structure starts changing fast. When heat enters, water becomes pressure. As heat moves through the shell, the water trapped inside starts turning into steam. Steam wants space. It pushes outward, looking for a way to escape, but the pericarp holds. So the kernel does not simply warm up, it begins to pressurize. Inside, the temperature keeps climbing. The water becomes hotter. The steam pushes harder. At the same time, the starch in the endosperm starts to soften. Under heat and pressure, it turns into a thick, gel-like mass. That is why popcorn is not just a dry seed cracking apart. It is pressure cooking itself from within. The heat changes the starch so it can expand later instead of crumbling like dry dust. For something so small, the numbers are surprisingly intense. The pressure inside a kernel can reach around 135 pounds per square inch, about 9 times normal air pressure. The temperature can climb beyond 180 degrees Celsius. And still, for a moment, the shell holds, pressure rises, the starch softens, the steam has nowhere to go. Then the pericarp fails. It does not open politely, it ruptures. That sudden break is the sound we hear as a pop, but the real transformation happens immediately after the shell gives way. Why the kernel turns into a white fluffy shape. The instant the shell breaks, the world inside the kernel changes almost violently. The pressurized water flashes into expanding steam. The softened starch is forced outward with it, pushed through the broken shell before it has time to stay in its old shape. For a fraction of a second, the kernel is not really a kernel anymore. It is an edible explosion. The starch rushes out, stretches, and fills with tiny pockets of steam. Then it meets the cooler air outside, which helps the expanded starch set before it collapses. This is how a hard yellow seed becomes something white, crisp, and full of air. And here is the detail many people get wrong. The fluffy white part is not the shell. It is the inside of the kernel, expanded and turned outward. The shell remains only as the small brown flakes you sometimes see stuck to the surface. In other words, popcorn does not simply crack open. It turns itself inside out. No new material appears. Steam stretches the starch into a foam, and the foam hardens almost instantly. A burst of pressure, a flash of cooling air, a seed becoming a snack. And if that sounds easy to copy, it leads to the next question. Why not dry any corn kernel and make it pop the same way? That is exactly where most corn fails. Why sweet corn and canned corn do not PO? Sweet corn is harvested young. Its kernels are soft, juicy, and full of sugar. That makes it delicious on the cob, but not ideal for popping. It does not have the same dry, sealed structure needed to trap pressure inside. Canned corn is even further away from the process. It has already been cooked, soaked, and processed. By the time it reaches the can, the kernel can no longer behave like a tiny pressure chamber. Other dried corn may look more promising, but hardness alone is not enough. If the outer layer has small weak points, steam escapes before pressure can build, and if the starch inside is not suited for expansion, it may crack, burn, or collapse instead of forming that white foam. So the problem is not that these kernels are not heated long enough, it is that they were not built for this kind of transformation. Popcorn is not ordinary corn cooked more skillfully. It is a version of corn shaped by nature and by cultivation to do one job unusually well. A small clue in your kitchen. There is a simple way to see how delicate this system is. If an old bag of popcorn leaves behind many unpopped kernels, the problem may not be your microwave. Some kernels may have lost too much internal moisture over time. Without enough trapped water, they cannot build the pressure needed to burst. That is also why storing popcorn in a sealed container matters. You are not just keeping it fresh, you are protecting the tiny amount of water that makes the whole trick possible. It is a small kitchen detail, but it reveals the bigger idea. Popcorn only works when its inner conditions are just right. A natural design, perfected over time. No machine invented the basic trick. Nature produced kernels with a tight outer layer, the right inner texture, and just enough trapped moisture to turn heat into pressure. Then, over thousands of years, people kept growing the kinds of corn that popped better, tasted better, and stored well. So popcorn sits at a small crossroads of biology, physics, and human choice. It does not need advanced technology to explode. A hot surface is enough. But inside the kernel, the design has to be surprisingly exact, and the next time you hear popcorn crackling in a bag, you may not hear it the same way again. Every pop is a tiny physics lesson. So maybe the smell of a movie theater is not just butter and salt. It is also the smell of millions of tiny explosions happening inside a paper bucket. Each piece of popcorn begins as a hard little kernel with a hidden system inside. Heat turns that system on. Pressure builds. The shell breaks. And in a blink, the part that was hidden becomes the part you eat. Corn on the cob, canned corn, and many dried kernels cannot follow the same path because their structure was made for something else. Popcorn is more than a snack. It is a small experiment in heat, pressure, and natural engineering that happens right in front of us. If you enjoy the small stories hidden inside familiar things, subscribe to Secrets of Simple Things and keep exploring the simple details that are not so simple after all.